Alright, so welcome back. So today we will talk about input-output in C++. So how to get data in, and well, also how to output. Of course, we already used syn and cout already in the previous lecture a little bit, right? So it's a little bit, it's same idea as many other languages, of course, just of course with some differences. So I will see about showing you slides a little bit, right? We'll do some slides as usual, and then hopefully we'll get also replicable work on this computer and this connection, and we can do some playing around, testing some things out, right? So again, so when you're dealing with input and output, the main thing is it's not a set data, but it's a stream of data. Like as Heraclitus said, you know, you can't step into the same stream twice, right? The ancient Greek philosopher, right? So streams, well, they tend to run out eventually. Actually, they change, right? So we will examine what the input is and output is. One thing you should remember from this, streams are useful because there could be more than one type of stream. You have a input from a console, an output to console, but stream could be coming from a file, stream could be coming from a network connection. So it's a good generalization, like an abstraction, right? So many things work, which work similarly with a textual input from a console, will work similarly with stream input from a file or from a network connection, right? So we'll look at some of the functions, right? Also, again, C++, again, you do have some low-level, you have to deal with low-level errors. Basically, what happens if there's a wrong type of input? If you ask person for an integer and they give you a string, a text. Also, we'll look at how to format output a little bit. Okay, so I/O, input output, of course we all know by now, right? Usually we get information in bite-sized chunks, right? So cat type, right? 256 possible values. And again, already you can predict that this is going to be a problem if you're expecting Unicode, of course, right? It's not going to be just one byte, of course, right? So stream, sequence of characters from source to destination. And of course, input is what's coming in, right? Again, it could be multiple type of streams, and output coming out, right? So iostream, right? We use iostream which contains input stream, output stream, right? And of course, we have a syn and cout is already predefined for you. Common input, common output. Let's see what does. I don't trust this book 100%. Again. But we can check CPP reference, iostream, right? And let's see what they say, right? This is more authoritative, right? Also pay attention to what version of compiler we're using, but this is C++ 11, which is the most standard these days, right? Well, pretty much any compiler will support this, right? So base class, iStream, OStream, like the book said correctly, defines some specific data types, right? Right, namespace syn cout, there also C error, right, for logging, right? Also, W is going to be for wide, I believe, right, or right, www, yeah, I believe, let's take a look, for example, here, syn and wsyn, right? Well, actually, notice, right, so the book, yeah, like the book was not correct completely. Again, C++ is full of these little tiny, naming things. Like the book said common, right? Actual, according to the actual character of the language, it's actually not common, but character. Does it really matter? Of course not. It's just a naming thing. But yeah, it comes from character, right? But it does make some sense. Character makes more sense than common. Common is just a name. Character does make sense because it means it's a character base. Byte by byte by byte, right? There is also WC, right? Wide, right? That implies more than one character at a time, possibility, right? Very important difference, right? So that's something to consider, right? So FN, right? Right. So we'll look at some of the things we can do, right? So syn cout, right? Include iostream, right? Let's look at some examples, right? So if you want to get something, right, So you type, you expect what you want to get, right? Sin, right? And you have multiple more than one variable. Let's look at again C++. This standard examples, right? Here's my standard init. Init, right? External right in. Basic manipulators. Right. So that's something again in Python would be input, right? In C it would be scan or cscan, I believe, right? If I remember correctly. I haven't written C in a long time. So lots of different manipulators, right? We want actually sin, right? So sin. Let's look at the example here. This is in a Cortus. I put this. You should be able to say this as well, right? So input we define I and n, right? So you want to have this do this test called math function, right? I will do some testing. So I to the power of n, right? We have power function from math, right? We have a iomanip for manipulating input output. Maybe we should make this a little bit bigger. You can see, so yeah, like this, right? And I don't need this right now. We can hide this. I think I can just like this. Okay, right. Now on the simple program, right? And then we have a couple different manipulations: overflow, possibility, right? Integer. Power function, right? Again, the types. What are you going to get out? If I'm saying integer, right? You call something to the power of something. It's possible you may not get actually the correct, in my overflow, right? Integer, 32-bit integer only has space for up to 2 billion, roughly about 2 billion values if it's signed, right? So by default, integers are signed, right? Meaning there's negative and positive. Negative 2 billion, positive 2 billion. And of course 2 billion something, and this is a little bit extra. Okay. So also here already we see some of the formatting options. Again, it's not as nice. I mean, obviously I like F strings. Like most languages, modern language these days have some sort of formatted string options, like in Python. C++ is using, again, slightly more old-fashioned ways, right? So for example, here you say how much width you want, right? And then you have the enter, right? You actually what you're going to display, and then you have the end flush, right? The end line which flushes to the stream. So what does flushing means? This means actually you see it, right? Because it's possible, it might be more optimal to do a lot of work. On flush stream, you prepare your buffer for what you're going to output, and only flush at the end, right? You have this big, you have to display a lot of text. It's going to be more optimal to display it all at once than doing row by row by row by row, right? Again, because printing something to outputting something to the console is very, very expensive operation. I mean, one of the slowest things you could do, right? Calculations, no problem. Calculating billion items, no problem. Outputting million items rows, that's going to be slow, right? So let's run this. I'm going to compile it. So I remember again, I'm not using the build tool. I'm using it by hand, G++. You can also specify. I'll do all warnings will be provided, and I have name of the function my mass, right? Right. Name the your source code can be called anything, but of course, if you want to run it as a program. If you're not going to make a library, you need the main, of course, right? And also, what do we else want? We want output for now, right? Output, mathy, or something, right? Any warnings? Let's see. Okay, no warnings. Okay, that's a good first step, right? So let's run it. Yeah. So let's see how big is it. Oh, I have a function. So they're called mass. Yeah, today's tens, right? So 16 for 8, 16 kilobytes. Pretty small, right? Of course, it's relatively heavy because, of course, it had to include some things from these libraries, right? From iostream, also the power function had to be included, right? From CMass, right? Again, when you're including CMass, of course, there's many more functions inside, right? But of course, when you're compiling, all the things you're not using, they're not included, right? Compiler is smart, it will take care of things for you. Okay, manipulation, right? So if you don't include this, you won't be able to set the viz and all these extra things. And all of those are part of standard. All of these, above all, are part of standard. All part of standard namespace. Come on. Okay. Right. I'm pretty sure it's correct. Now, CMath, I think, yeah. So otherwise, for example, power, right? You see, example says std power, right? And set to the w, std, right? So if I didn't have this, I have to do for every function, every manipulator, I have to use std : : . Okay. Now let's run it. Math. So as floats. Okay, but I said floats, but am I really getting floats? I'm lying here, right? I'm saying actually integers, right? Let's try this. What is this 16 doing here? Why is that 16? What is this 16? As floats. It's interesting. Yeah. Notice what's happening. What the heck is that? Remember what's going on here? This shouldn't be here actually, right? Why? So that 16 is I declared n, right, as an integer, right? And this is pure garbage. This is pure garbage. This is pure garbage because we did not initialize. Yeah, right. So this should have obviously, for normal program, this would be a mistake. I'm surprised that it didn't pick up on this. The warnings when I was compiling, right? I was kind of depending that they would pick up on these stupid things, right? I mean, nothing horrible will happen if I'm just outputting, right? If I was doing something more complex, right? There's absolutely no guarantees what the value of n. There's no guarantees. There are no guarantees of what n is. Yeah. Right. Okay. So I should probably, I'm going to recompile. I don't want to see random garbage, right? I mean, I can run it, of course. So 10, 2, right? Yeah. So everything works. And why is it? Power 2.6. Okay, everything works. I'll leave this off for now. I don't know why this is. Let's try to overflow some things, right? Yeah. And I should probably, okay, save this. It's automatically saved, so I'm going to do arrow up, arrow up, arrow up. Of course, it works in most code editors. Arrow up is a great time saver. Now, if you never use it, you should, right? Because we're all, what's a good programmer? A lazy programmer, right? Yeah. So, anything that makes. That's why even Bill Gates says they won't hire a lazy programmer because they'll figure out how to do things with less, right? Not completely, you don't be completely complacent, right? It's different between lazy and complacent, right? So, now, compiled again, no errors, okay. Let's run it now. So now, yeah, so I don't have any random garbage. So what's happened here is, of course, if I didn't have this end line, my input would be in the same row, right? So since I flush the input, I'm getting it here, right? Yeah. And so let's do what? Let's do some big numbers. So let's do 1,000. Let's do 1,024, right? That's 2 to the 10th, right? And what power are we going to raise? We're going to raise it to 3. That would be what, billion? That would be about billion, right? Okay, so let's look at a couple things. Now, nothing is overflowing. Overflowed, also overflowed, but nothing is overflowing because, of course, you still have space, right? So this is 2 to the 30th, right? Let's do 2 to the 32nd power, right? So in set viz, interestingly enough, here the first two entries, right? they are using setviz, right? And they're using this basically also sets that if I'm using this manipulator, right? It also adds scientific notation, right? So you have to read about ZW. We'll see this more in action later on. So let's overflow. Okay, I want to break things, right? That's why we're here, to break things, right? Move ridiculously fast and break things, right? So 2, and I'll do 32, right? Let's take a look. All right, okay. So this overflows, right? So finally we got an overflow, right? Why? Because we went over, right? 2 to 32 is about 4 billion, right? An integer 32 didn't overflow. So this didn't overflow, right? Why? Because it's a long, and long is 64 bits, right? So we have space. So how much could we offer? Let's do 2 to 64s, right? Or 2 to the, to be safe, let's do 2 to the 64s, right? Okay. And finally we get to the overflow section. Look at this here, right? So this is negative because it went over, right? Of course, eventually get positive again, right? But of course, once you only have so much space, right? Only 4 billion different values, right? You guys are all clear on that, right? How about also overflow again? 64 bits not enough because again we went over. We're only using 63 bits for each side, right? 63 bits for positive, 63 bits for negative, and we have sign bit, of course. Now not overflow. So pay attention to this here. So auto. So basically, I wonder what data type is auto, right? It's probably going to be, but I am guessing it's going to be probably long, probably, right? Right? Now, it's not as nice. We don't really have a good way of showing what type it is, but let's see. Print the data type of auto. Print data type of auto. Unfortunately, this Replit AI is not so good. I'll go to open sidebars. Where's my files? What was the none used last time? Was it main? I forget now already. We use main. Yeah, I think we did. Or did we? Yeah. This one here. I guess type ID worked. Let's try type ID. Get lazy. Yeah, type ID. Okay, so AI finally picked up on what I want to do. All right, let's see if this works. So I'm going to compile it again. It's amazing. Arrows again. Mass again 2 to 64. So I think it's going to be long. Maybe something, I don't know. It's going to type. Right, it's D basically. Well, it says just D, right? So not really useful. I forgot if there's a way to make it really nice, because it's sometimes, of course, if you have an IDE, a good IDE, better than Replit, right? It will tell you what data type it is, right? So it's D. So it has enough space. So again, we will look at the basic data types, C++ data types, right? Not WT schools, no, C++ reference, don't, problem is some of the other references, they're not authoritative, meaning they might be right, 99% of the time it's right, and they might be wrong. It's more likely the CPB reference will be correct. So long. Okay, here's the thing. These are guarantees. Notice, standard says at least 8, right? It doesn't say what's the maximum, right? So at least 64, even if you do long integer, right? Look at this scenes. So 64 bits, but do you get 128? No guarantees. So long, right? The long here is 64, but is long 128. You have to look up your compiler, right? See actually what does it guarantee, right? So we can also get size off, right? That might be it actually, right? Let's get size. Yeah, that might be good. So not very useful. Let's get size. let's get size of not overflow. Yeah, this might be more useful. I'm curious, right? Size of. Yeah, I'll put it here. I'll put it here also. Where did I put it? Okay, so size of overflow. On size. Size of overflow. And also overflow, right? Also. Okay, size. I'll close this so you can see this size of also overflowed. Size. Okay, so let's now see what happens now. So we have some more information. I'm going to compile it. Hopefully I didn't make any typos. No typos so far. Alright, so again 264. What happens? Alright. Okay. That's very interesting actually. So why didn't we have overflow? So it automatically picked on so this this auto, it looks like it's long unsigned and then it still works, right? That's very interesting actually, right? Or maybe it went to a float. That's very interesting. So let's try this again one more time, but I'll do something silly like 2 to the, I don't know, 80th, right? That should be, you know. Right, okay. So now we see what's happening. And of course now overflow, it keeps alternating. So to 80th it's even, so it keeps going around, right? So that's why it's still about the same number. Also overflow size 8, but so it looks like, it's very interesting actually. It certainly looks like that auto decided to go to the float actually, right? That certainly looks like. Okay, that's my explanation. Again, why? You have 8 bytes, right? You cannot put all different values of 1 to the 28th fourth power of 10, right, in 8 bytes. The only solution is use the floating point value. This means, of course, you will lose some data at some point, right? So this looks like for large values you would get float. The question now is, will we get float for small values? Double float, double. Right? Okay. Now, let's do something. Experiment. Let's finish experiment 2 to the 10, right? Okay. Yeah. So it looks like, certainly looks like it is float again, but D, right? Double. Yeah, it's double. Yeah, it is double. Yeah, you get double. So power. So where did this come from? Well, the thing is, power is actually multiple functions, right? Expression. Actually, there's a macro there. We'll get to macros in a moment, and later on in some other lectures. Basically, it's hiding a lot of complexity. This power function, actually, right? There's multiple implementations, right? So, but again, so let's take away again. If you want to be relatively safe, you can use auto, but of course, you might not don't have this fine guarantee of what you are going to take. But going back to our input, right? I know many beginners tell me, yeah, they really like this C++ input, right? Because it's in a way it's nice because, yeah, if you're holding good values, right? It works great, right? But let me put some garbage in. Let's see what happens if I do some garbage. No, let me put some floats, right? I said integers, right? What happens if I do float? I said for float. I'll do like, okay, so I'll do 4 to the power of 0.5, so square root, right? So integer and float. I wonder what's going to happen. I am thinking it's going to be 0. So it's going to be, answer is going to be 1. I'm thinking it's going to be 4 to the 0, I think. Any other guess? Maybe 1. So maybe, I don't think it's gonna work. Why? Because integers, right? There's no floats. There's no floats. There's no way of getting float. I mean, as standard input, right, stream, I'm holding integers, right? I'm not casting to floats. There can't be 0.5. So my guess is what's going to happen is 4 is already input, I is 4, right? But n is going to be how much? 0, right? Because, and then, it could be error, but I think it's going to be 0. Yeah. So it is 1, 1, 1, 1, right? Because it's 0, right? So exponent is 0. You see, exponent is 0. Yeah. So you did your best, but of course, since I did integers, so how do I fix it? Well, I'm going to be lazy. Shift Alt again, right? Shift Alt arrow. You know, Visual Studio Code has this. Many multiple IDEs have this shortcut, right? I'm going to double the line. I'm going to comment this out. I'm going to do double, right? Let's do double, right? Again, def doubles, right? All right, let's see what happens, right? So now it should work, and let's take a look what happens now. So math, well, first I need to compile it, right? It's going to work. Yeah, it worked. Okay, math. So let's do 4, 0.5. Now it should be 2.0. But again, auto might be close to 2.0. Let's take a look. No, it's still 2. Okay. So, again, just have to remember, of course, what if you're seeing 2, right? We see an example of arrow. You see some example of fill functions right here, right? You see some space, some examples, just some things so that you can format text, right? So size 8. So yeah, answer is correct, right? 2. Again, I would like to break things, let's see, but play around, enter some evil values. But again, remember, we are seeing the console output with certain, formatted output, right? We don't really see the full float value, right? Double. When I say float, I really mean double, right? In this case, right? Because we rarely use floats. We use doubles mostly, right? So yeah. So. No. Okay. Okay. So, any questions about this so far? Any of these parts? We'll get some of these. We'll see them in the slides. We'll cover them maybe a little bit more in detail. So we have data, have of course obviously size, right? What kind of data we determine, what kind of we are casting, right? When we get results on some function, we are casting to specific data types. Let's get something more, maybe something like, I don't know, what kind of power can we take? Let's say, I don't know, 5. Let's do like, I don't know, 5.5 on power, again, 0.5, right? So that's like a square root of something, like 2 point something, right? I know it's sleepy, right? So, again, base 5.5, exponent 0.5, right? Not overflowed, right? So you do see something here, right? So I cast to int or long, all the floating point part is gone, obviously, right? And it's gone forever, right? If I didn't have another variable, right? So, so you see this 2, 2, because again, I said, okay, I want integer, I want long, right? So auto said, okay, this is a float, actually it gives you a double, right, the value, right? Okay, so far, let's see here before the break. Actually, we're going to have, I guess, break in about 5 minutes. Let's see what the slides say more. So, input, right? So you can do multiple sins, right? Multiple sins, right? So it skips, yeah. So sin, ci, sin skips white space, right? Kind of nice, right? Right. So number 2, but right. Yeah. So again, depends what kind of variables you have, right? So sin, right, one printable, right, except blank, except white space, integer, you know. For integers, you can have plus or minus. I mean, for, well, plus you don't really, technically you could, but I mean, nobody really enters plus, right? I mean, that's useless, right? But it will accept it, right? So a decimal number, right, again, so if you input integer, right, you still get double, right? Yeah. So input fail. So let's try to break things before break. Before break, let's break things. So let me put some evil values inside. Of course, that's what causes many C and C++ programs to break, right? If the input failure is not handled properly. So I'll put Valdis. All right. So what the heck happened? Right. So enter base is 0 and exponent is 3 to the negative 313th power. What the hell happened, right? So, excuse my French. So, pardon my French, right? So, base 0, Valdis, right? So you try to cast, right? So you try to cast V to it's double, right? Because these are floats, right? So I try to cast, but I entered as, so I entered VALDIS 5, and I pressed enter, right? So it's kind of funny. So 4 letters, I believe, will be 4 bytes, right? As floats, well, double. So 8 bytes. Oh, so 0, right? And N actually was not completely covered, I guess. So pretty silly results, right? So let's do something a little bit better. One more time, Valdis. So I'll put like 10, right? And now I'll put like RBS, right? Let's do R. Again, so exponent 0, so we get 1, right? So again, we actually get failure, but the thing is, why did we have this 3 to that happen here? It looks like, most likely, then don't quote me on this, but most likely it's taking, N actually does not assign any C actually, right? This is original garbage value, right? So there was a failure, and we didn't actually, we just sort of, we blowed ahead with our values, right? Not checking whether everything was okay. Of course, in real life, this could lead to problems. So we have a way of testing whether the buffer actually, whether this is good or bad, right? So, input failure, right? So, reading, right? This is actually set. So sin, right? Again, these are all correct ones, right? These are all fine, but let's get to the bad values, right? Main, right? To define functions, okay? Get files. This is all basic stuff. Yeah, power function, right? This we're using. And sim get, right? So we can use find basically you can use also a get function, right? Which is like more fine-grained function. But I want to get to the failure function, right? We can also ignore, but do a gradual input basically, one by one. Let me get you the failure ones. Fail, peak. We can also peak, right? This goes back to even all the many languages have this. You sort of you have a stream, right? But you don't touch. You look, but you don't touch, basically, right? You don't grab it. You say, okay, what's inside? What's the next character? Right? Is it good? Right? You can check it, right? But you don't. You keep it in stream, right? So you sort of you can use it, of course. You can assign something, right? Right? You can also put stuff back actually as well, right? So it really depends, of course, if doing some low-level stream processing, this might be very useful. Okay, but I think we're getting kind of sleepy. Let's see, 11:50. Let me see. I want to get to the failure. Fail. Yeah, put back. Peak will get us afterwards. But I want fail. Yeah. So fail state. Right. So this means that if you fail, right? This happened with our program, right? Program continues to execute whatever values are stored in variables, right? So we could clear it and do it again, of course, right? But we also can do get this failure state inspected. and we hopefully will get after the break. All right, if we have a break, we can check state. Inspect the scene state. Yeah, fail, right? Or not. Yeah, not. So, not in the fail state or yes, right? So, what's happening here in this line? You can tell me, who knows this, who remembers from C classes? What is this expression? Do you guys remember? Ternary, yes, ternary expression, exactly, right? So, basically, it's lazy programmers, right? You don't want to have if, it's like an if statement that we said we assign it here. So basically, you'll either get this part here, this one white space, or this not with white space in between, right? We're asking, this is true Boolean, right? Boolean, we get a Boolean, like the signature is Boolean. So if it's true or false, we're going to give one of these values, right? It's kind of like nice, it leads to having nice compact code, right? So, well, I would say nice but compact, right? Maybe sometimes you can make things very unreadable. If you have too many ternary expressions in one big line, in one big row, you won't be able to understand. But this is okay. Again, okay, decent AI support here today. Let's compile it. Okay, let's run this program before the break. I'll do something good. 2, 10. So, scene is not in a fail state, right? No fail, right? Let's try to fail it. So I'll do 10 to the power of all this. Scene is in a fail state, right? So what happened again? N was not assigned. N is whatever was in memory, right? Of course, if I had set N here, let's say N is I don't know 77, right? Let's do that, right? Right? Let's try this approach, right? So what's going to happen? Oh, I'll do like 7 basically. I don't want to do too much, right? It doesn't matter, right? But I'm going to compile it for the break. I know you guys want to. Now let's try this again. Math. So 10, 3,000, easy, right? Let's do it again. So 10 and all this. Okay. What happened? Actually, fail state. Oh, that's interesting. That's actually even more interesting than that. So N actually was assigned garbage, actually, not kept. I thought this N would be 7, right? But it looks like N was actually completely with this. It failed. So N was assigned something, but actually was a garbage, actually. So again, some experiments again with C++. Okay, so we'll have to, after the break, we will handle the failure. We'll do something, right? So we can do something with if people, because we expect that people will enter garbage at some point. All right, so let's continue at 12:10. And I'll stop this recording for a moment.